Alright, so welcome to this course. And today we're gonna officially get into something about object-oriented. Okay, now we start with the concepts regarding what is in the OO area. Okay, so it's the object-oriented concepts. What is an object? What is an object? You know Java, you know, right, C++, those things, right? What is object? Not looking at the slides, but just briefly introduce what is an object from your opinion, based on your understanding.
I think we could say an object is like an item that represents a true concept in the real world. So it envelopes the characteristics and like what it can do or what it can serve for.
Yeah. So it's something that it can do something, right? Some object that can do something, right? So it is very solid. Well, a thing that exists in the real world that can do something, right? Objects. And in the computer, in the subject-oriented programming, object is the thing that really exists in the memory, the code, no matter the code, the data that really exists in the memory that can do something, has some functionality there, and has state. Okay, so here the official concept object is a software entity that mirrors the real world in some way. Well, when the object is a very solid thing, this kind of concept is kind of abstract, right? It's a mirrors the real world in some way. So what is the some way? What are those? How it simulates the real world in some way? Well, that's the whole concept behind. Because object, they are created from a class, right? A class is kind of a generalization or categorization of the things in the real world, like a class of teacher. So I am an object of teacher, right? But teacher is not a person. It's a concept that it category, in this category, like those people who offer class, who give lectures to students, we call teacher, right? So we categorize those people as teacher. Okay, so it does, in the real world, there are people there who is giving lectures as a teacher, and well, the class of teacher just mirrors the world in that way, and an object of teacher, it mirrors the world because the class defined it that way. Okay. All right. A software object in object-oriented programming has some elements. One is data. It's the attributes. Like teacher has the maybe attributes of age, name, gender, something like that, and code that responds to the instructions. Think of code and the data as being welded together. So, well, the code is like the function to manipulate, to do something in this object, like giving lecture. That's a function, right? So it will control my maybe attributes like my mouse, my mind, the open, shut, and give the sound, something like that, right? So that's the code, the kind of like the code that controls my behavior, right? So okay, so here the whole thing behind AAP is the code completely wrapped with the data together. Okay, so that's well, we call it a class, right? A class. It has sections as the attributes and functions. The functions do something to the attributes, right? Okay. So just keep that in mind. What is an object? It's something that really exists. Okay. In the real world, in the memory, the object exists there. And the object has a state, behavior, and identity. What we know what is behavior, right? It's functions like I'm giving lectures. Identity is the object that identify the object. Like it has a certain place in the memory, right? You can find that certain object. That object is that object. It's not the same as the other object. And me as a teacher, so I am here. And the other teacher is another object of teacher, but we are not the same person. So we have different identity. But how about the state? What controls the state of an object?
What does state represent here?
Okay, state, yeah, that's the question I'm asking. Yeah. Like, okay, for example, me here, I'm an object, right? It's a phone call, let me end it. I'm an object, okay. So I have a state, maybe I'm speaking, it's a state. I'm not speaking, it's another state, right? So the state, actually, we have function to control this behavior. But what the function control is actually my attributes, my mouse. It makes it open, shut, and make sound, right? So that function controls the attribute so that I have different state. Okay, so the state is defined by the attributes. Okay, remember that. State is defined by the attributes of that class, of that object. So the line is as on and off, right? We should have an attribute. It's called on or off. Well, true. We set it true, set it to false. So it has a state. So object encapsulated all this state, behavior, and this state, behavior, and attributes. Those things we all wrap them together. So they are the object. Yeah. When we talk about object-oriented, the other side of it is procedural languages, right? So what is procedural language? So here's the function. So here's the example. C. Fortran. You using any of this? At least the C, you learned that a little bit, right? Yes or no? Okay, that's fine. So yeah, when we have this idea, this concept of OO, it's actually related to the procedural languages. Yeah. So what's the difference between these two? Well, you know something about procedural language. When you're programming with C and the C++, what's the difference, do you feel? And we have mentioned one of the key differences there is that the encapsulation. Encapsulation, right? We don't have in procedural language, we don't have the concept of a class object. We don't write those together, right? So yeah, but in C, well, recall when you conduct some work with C, but it does have some similar components. Does it have a lines of codes? It has, right? It has the data variables. Does it have variables? Right, it has variables, right? So it has the data and the variables. Yeah. But data is data. Code is code. They are not encapsulated in some certain place. They are not encapsulated in one certain class, right? So it's just functions and the data there. But object-oriented language breaks program into tiny entities that have small bytes of code and the data. Okay, so they are fused tightly together. Well, subroutines are convenience in a procedural language. The separationness of these entities is essential to an object-oriented program. Okay, subroutines and the class are two different concepts. Okay, subroutine is when you conduct a procedural language, it maybe it goes from this method, it's called another method, and it's another function area of functions, a section of code you may go to the next. Yeah, but the class is organized in a different way. It's actually simulate how human beings are learning the real world, how human beings are solving problem in the real world. Okay, so it organized differently. And there are a lot of benefits of organizing in a way that's similar to human cognition. Okay. So object-oriented programming is a new way of doing conducting programming, and the underlying idea of object-oriented techniques, the same basic method humans use to solve problems in the real world, like I mentioned. Yeah, abstraction, things like that. Yeah. So there's an interesting fact that, well, if you're new, you do not have any pre-knowledge of procedure language, or your children, maybe you grab the idea of object-oriented programming easier than computer professionals. Okay, because the professional has the professionals, they have too much knowledge in the procedure programming, which is C or something like that, so it makes it difficult for them to switch from one to the other. But here today, I think it's not a problem for us, because when we actually start our working or start our courses, we more or less have been exposed to object-oriented already, right? If you know, well, sometimes we have our first language as maybe Python or Java instead of C. Okay, but if you go maybe turn a decade or 2 decades ago, the first language, it won't be Java or any object-oriented. We always start with this procedure language. So that's not a problem for us here. Okay. So the terms of class and objects, I've mentioned that a little bit. So object is something solid, really exists there. But class is, in real world, it's a concept. In the code, it's a class, it's a template from which the objects are created. Okay, so it's a segment of code. When you are writing the code, you're writing each class. But when the machine is running the code, it runs this code as each different objects. Okay, so it's a class. It's a template from which the objects are created. Like me, maybe created from the class called teacher, or I may be created from another class called the human, right? Yeah. An instance, well, it's similar to object. So its instances are individual objects created by class. Every object is an instance of class. Okay, so instance, well, just objects. Initialization is the process when you create a new object from the class. Like if you're using Java, like new teacher, blah blah blah, right? The new is the process of initialization. And method, we don't know that, right? Method, so it's a behavior of a class and all its instance. It is described by a method. So the method here is similar to the method in procedure program languages. So they execute it step by step, right? And they do branching and looping. What is branching? Anyone knows what is branch? Branching in the code. Oh, you code, right? You do coding, right? Can anyone give an example of branching? You know loop, right? Like a while loop, for loop, right? That's loop. So branching is, you know, if else, right? That's a branching, right? So if we go this way, else we go this way. That's a branch. All right, yeah, you know that, but maybe you do not use branching for that type of thing. Yes. Okay. It take arguments. You know arguments, right? So it's the variables that would take. It's the method will take when we call it. And have local variables, and it has return values or return objects. Yep. And method, something about methods are unlike the procedures. Okay, they may only access data of the class for which the method is defined. Right? It has an instance data can only be accessed through its class method. So that's actually in the very ideal or pure object-oriented idea, pure object-oriented design. Okay, ideally we should only access the data of a class, of an object, through its method. Okay, but well, you know that we sometimes, for to be more convenient, we use, like we define in Java, we define public variables. With public variables, we don't have to call a method. We don't have to call a get method to get that data, right? But actually, when you define this public variable, first, it's highly not recommended to define a lot of public variables, right? Because of well, it sort of violated the idea, encapsulation. And then if you learn a little bit deep down there of the implementation of Java, when you call the public variables, it actually has a get method, just it's not defined by you. It has a get method there to get that data, the value of the data. Okay, just not the, you do not define it. They are defined automatically. Yeah. So it's still access. You access the data through the method. But in procedures, it's different. So you access the data within some certain scope, but that scope is not organized as a class or objects, anything like that. Yeah. So there's a notice, a class method completely encapsulates the data of objects of the class for which they are defined. Yeah, in the ideal situation, yes. And what are messages? So a message is a request to specific instance called the receiver to invoke specific method. along with the name of the method and the argument, some additional information can be passed as part of the message. Okay. We just mentioned that the method is defined within the class, within the object, right? But if you want to access the other class's method, so what you do is the message. Okay, so well, you have two instances. Okay, like me is instance, you are instance of a student. I'm an instance of a teacher. So if I want to call if I want to, like, you have function of finishing the assignments. Okay, so maybe I have a function that to give the assignments to you. Okay, and one of the part of my function of giving assignments is to call your function to finish the assignments. So here what I do is I cannot just say, I cannot control your mind, say finish the assignment. What I do is I'm sending the message, please finish the assignment. Okay, this is the message I send to you. Okay, if you want additional information, please finish assignment number 1. Please finish the final projects, right? That's the arguments, right? So that's a message. Okay, so it's used between instance to maybe invoke the method, different method. Okay, so I want you to do something, I send message to request. Yeah. Well, okay, but what difference is here, you may or may not receive my message, because you can ignore my message, but in computer most of the time the message will be delivered to the other instance. Yeah, that's the difference there. Okay, we know what is message. Here it says when the object receives the message, it evokes the method for the selector. This can first change the object instance variables. So the method changes the variables, right? Like I mentioned, you change the variable. You control your hand to finish the assignment. Or send another object back as a direct response to the message. Or it do something in the real world of the computer, such as display information, print, or read a block of data from the file. So it just does, they have these behaviors, 3 types of behaviors. Yep. And most of the code within method consists of pass message to the other object, because we work collaboratively to finish some task. So does the object. So do the objects. Okay. And the terms abstraction. I talk about abstract. Okay, class is abstract, and the object is more solid. Okay, more specific, more solid. And what is abstraction? So here we define it as a problem-solving tool that allows one to think of a problem at a higher level without worrying about the details. A problem-solving tool, allowing we to think of a problem and without worrying about the details. So while this definition is abstract enough, okay, so we need something help us to understand this definition. So there are 3 abstraction mechanisms. We learn what is abstraction from here. The 3 of them are classification, generalization, and aggregation. Okay, let's see what are those. First is classification. So, wow. Yeah. So in classification, it forms new objects by surprising the details of individual instances and emphasizing properties of the whole. So new object types are formed by collecting instances. So here's an example. Okay, classification. Okay, here's an example. When we are trying to ignore the detail here in this classroom, we have a chair, black chair, yellow chair, green chair, orange chair, right? A lot of chairs here, right? So here we want to classification the objects in this classroom. Okay, so for example, we find out those chairs. Here we know there are chairs. We ignore the details, their colors, their details, right? Their position, they are different. Their details. Okay, we ignore those details. We emphasizing properties of the whole. So the properties of the whole is they are sitting here for you, for everyone to sit there to listen to the lecture, right? So we can classify them together as the same category, chair, right? Or there's another way here. We can ignore the details of the difference between us, right? No matter we're teachers or students, right? We're all human beings, right? So we classify all of us as human beings. The chairs, we classify them as like the tools or something like that. And computers, right? You have laptop, desktop, or cell phone, and they are doing some computing work. We can also call them computers, classify them as computer, right? So there's a classification. So we form new type from the instances, right? There are a lot of instances here. We don't have a new type. We're trying to categorize. We're trying to classify them. That's classification. Here, classification allow one to collect the instance Jane, Bob, Sue into a new higher order type called secretary. Okay. The yellow chair, black chair, blue chair into a higher category called chair. Okay, then what is generalization? So generalization merges existing types to form new types. Okay, we have types already. No more. Well, we're not talking about instances anymore. It's about types. We merge existing types. Individual differences between subtypes are ignored, and common traits are emphasized. Okay, so can you give me an example of that?
Like SUV, sedan, or truck.
Yeah.
They all come.
Yeah, exactly. Awesome. So we have SUV, we have truck. Okay, we ignore what the different types of cars, or you call vehicles or cars. Okay, so we can merge them into a higher type, which is called car or vehicle. Okay. So it's we can describe it as is a relationship. What is it like? SUV is a car. It's a type of car. Truck is a type of car, right? So that's generalization. Generalization. Like existing employee type, secretary, teacher can be generalized from the new type, employee. Okay. So that's classification and generalization. Yeah. Well, when we merge these two, we can another important principle here or attributes here is when we merge them together into a higher category, an instance of a subcategory is also an instance of the higher category. Let's still take the example of the SUV. Okay, so maybe your SUV, say, well, which one is the most popular SUV today?
Like black Outback.
Okay, Outback, black Outback. That black Outback belongs to you, which the plate number is XYZ. Okay, so your SUV, well, it's an instance of SUV. It is also an instance of car. Okay, so basically that explains it. That's an important principle here. And another concept is aggregation. So it forms an object as a relationship among the other object. It suppresses the details of the components and emphasizes the details of the relationship as a whole. So it describes is part of. Like here, like look at your around you here. Maybe the glass, and you as the object, and the glass as an object. The glass object, the glass you're wearing. Sorry, you didn't have one, but yeah, that's fine. But the glass you're having, you has a glass, and glass is a part of you. Okay, you as an object, glass is a part of you. Or maybe hand, if you have another object called hand. Okay, you can have a separate object called hand. Okay, and for instance of a student, it will have an instance of hand, or a collection of hands, a pair of hands. Okay, so that's called aggregation. That means the relation between two objects. One owns the other, or one has the other, or the other object is a part of another object.
Like computer and desktop and screen and keyboard and CPU. Is that
Yeah.
aggregation?
Yes, that's aggregation. Yes. And the CPU, keyboard, they can also have the aggregation relationship with the laptop as well. Yeah. And sometimes we can just make them an aggregation of the class of computer, because well, when they merge into a new computer class, they can have aggregation there. Okay, so we consider object type stove, refrigerator, sink, cabinet. Okay, all these objects. A kitchen object can be abstract from the given objects. So the individual objects are components of the aggregate. Okay. Instance of a component is said to be attribute of an instance of the aggregate. Alright, so hands become an attribute of us, and glass is an attribute of us. Okay, so when we're talking about classification, generalization, and aggregation, so they are basic ways when we are trying to learn the world. Okay, think about a newborn baby. He knows nothing about the world. Then he realized, okay, he said he or she saw the parents sitting on this chair, that chair, so he can categorize them, classify them as chairs, because they are all used to seat, for their parents to seat. So they know what are chairs. Okay, so that's the way we learn the world, and it's a basic way we have of structuring the information. And when they are repeatedly applied to objects, hierarchies of new objects are formed. Yeah, hierarchy of objects are formed. Hierarchy means like the car, SUV, that's a hierarchy, right? Car is at the higher level. Yeah. So these three things are the logic we use to learn the world and structuring information. So we also do that in object-oriented programming. So which make the object, with the idea of object-oriented more close to our mind, close to our cognition. Okay. And some other terms here. Information hiding. So it suggests the decomposing system into components that hide or encapsulate design decisions about abstractions. So it's highly associated with the encapsulation. Like I mentioned, you can call the method, but you don't know what's actually inside the method, how it does the things. Like I ask you to finish the assignment, but I don't know how do you do that. Maybe you copy from others, you Google, or you do something else. But that's information hiding, right? You hide the information, right? Yeah, so that's a way of understand information hiding. Because your function is encapsulated there. Alright. So data abstraction. It refers to defining data types in terms of the operations that apply to objects of the type, with the constraint that the value of such object can be modified and observed only by the use of the operation. Yeah. So that's another concept of abstract data type we will talk about later later today. Yeah. Data abstraction, thinking in terms of what you can do to a collection of data independently of how you do it. Okay, so abstract data type is a collection of data structured in a particular fashion together with a set of operations that manipulate that data. Okay, no worry, we'll talk about that after we finish the 3 slides left here. And inheritance, polymorphism, dynamic binding. Okay, that's important features here, or properties, attributes of OO idea, OO principle. Okay, so the inheritance is the principle of receiving properties or characteristics from an ancestor, and is used to define new data types as extensions or restrictions of existing types. Well, good example is the car and SUV. Okay, the car class will inherit from the SUV class will inherit some of the attribute properties from the car class, like the maybe I don't know, wheels, but all has 4 wheels, right? Or okay. So when we define a car, maybe we need something common in car is it's moving. It has an engine. It's moving. It has a plate to identify it. And so that's SUV. It inherit the engine, the section of engine, maybe windshield, the driving wheel, right? Steering wheel. Yeah. Also, it will customize its own features, like it will specify what types of engines, or it's going to adjust the height or something like that, and suspension, something like that, to make it an SUV. So, yeah. And polymorphism and the dynamic binding. We talked about that a little bit already. Like an instance of SUV is also an instance of car. So that is polymorphism. Says the program entities should be permitted to refer to objects of more than one class, and an operation should be permitted to have different realizations in different classes. Well, this explanation may be confusing, but just an instance of an SUV is an instance of a car. All right. So if we have a variable which is of the type car, okay, during runtime when we run the program, we can give SUV instance to that car variable. Okay, we can give the value there, or we can give the instance of the a truck to the variable of the car as well, because a car is an SUV, a car, and also it can be a truck, right? So yeah, that's maybe I should do it here. Like we have a car A, okay. We have a SUV S, a new SUV, something like that, and we can have a truck. Truck T. Okay, so dynamic binding means here A, we can give the value of S. Okay, it won't violate any rules here, or it can be a like if blah blah blah. A is S. Else A is T. You understand? So that is dynamic binding, because you use the ancestors here A, and so you can make it an SUV or truck. Okay, here. So both we give the value of S to A or give the value of T to A. They won't violate any rules here. Okay. So that's polymorphism, dynamic binding. The idea that my throat is really burning today. And yeah, polymorphism refers to the situation whereby a given program entity may refer at the runtime to instance of different classes. And the dynamic binding refers to the situation whereby runtime system will automatically select a version of an operation adapted to the corresponding instance. Okay. In multiple and repeated inheritance, it should be possible to declare a class. Yeah, some of the OO doesn't support multiple inheritance. Okay, like a car can inherit. SUV can inherit from a car. SUV can also inherit from what else? Okay, now SUV is not a good one. Okay, so the teacher can inherit from the class called employee. A teacher can also inherit from a class called human. Yes, great, good job. Yeah, so that's called multiple inheritance. Okay. Well, in Java, it kind of have a multiple inheritance, but it's not. It can only inherit from one class, but it has an interface. If you want to implement the multiple inheritance, you have to use the interface to implement it. Okay. So it should be possible to declare class to inherit more than one class and more than once to the same class. So that's the idea of OO. Okay. Like that's pretty common. So you inherit from your mom and dad, right? That's multiple inheritance. Sometimes it creates some confusions. So some programming language do not allow that or restricted that. Okay, so that's the terms about OO. Any questions in this part? Yeah, that's easy, right? So that's just remember this terms. Oh, I accidentally closed everything. Okay, let's talk about abstract data type. So let's not look at this definition first. Let's look at here, this structure. Levels of abstraction in specifying a data. So the top level is abstract data type definition, okay? And down here is the computer architecture hardware level of the representation of a data. Maybe 0, 1, 0, 1, 0, 1. So that's the lowest level of data here. Okay. Okay. Highest one is abstract data type. So, well, if it goes down, it's the implementation in high-level language, like array of customer records sorted on name field. Okay, so that's the implementation, and then we goes down to the assembler language. Assembly language is the machine language. x86 is kind of this commands that a little bit higher than the 0, 1 bits. Okay, if we do not care about this two level, we care about we care about higher level abstract data type. So what is the abstract data type? Okay. Data, we all know data type, right? Data structure. We know what is an array. We know array. We know linked list, right? So what are the array? When I say array, when I say linked list, when I say dictionary, are they abstract data type, or are they abstract data type, or are they implementation of abstract data types? Array and linked list when you started the data structure. Huh? The implementation. Well, actually, if we just say array and linked list, they are abstract data type. But if we say array in Java, or the array in C++, or the well, maybe double linked list in Java, or something like that, that implemented data when it is an idea of array, like linked list of cells linked by pointer. So that's an idea. If it's idea, then it's a abstract data type. Okay, only when you have some implementation in Java, like array, Java array, or maybe C++, they implement array differently. I believe that they're similar, but they're not, but they have their different implementation there, and we can array also if we have an instance of array, or there are solid implementation instead of abstract data type. Okay, so when we talk about abstract data type, that's the idea of the data type, data structure type. Okay, so okay, we know what is abstract data type. Now let's go here. When we want to specify abstract data type, there are 3 factors we need to learn, we need to define. First is a description of the elements that compose the data type. Description of the elements. Like well, there's an example here. Array. Can you see clearly? So the array, the ADT array, abstract data type array, is an association between an index range and a collection of identically typed data items. So that's the elements inside. Here, let's go back. A description of the elements that compose the data type. So array is index and the collection of some data type. Okay, so that's the element there. And second, a description of relationships between the individual components in the data type. Okay, so we need to define the relations of the index and the collection of data, the data cell. Okay, so here it defines as an index range is a finite collection of consecutive enumerated values such as integers or characters. The association between the index range and the data items allow us to designate the first value in the array as datum associated with the first index. So the i's value is associated with the i's cell, the data in the i's cell. So what is this defining? This is defining the relation between the index and the data. Okay, so that's second description of relations. The third is a description of the operations that we wish to perform on the components of the data types. What are the operations? What are the operations of an array? Operation of an array.
Operations like push, add.
Okay, push and add, that's kind of sounds like stack, right? But array is just maybe delete or maybe get, or here the operation destroy, retrieve, assign, right? Assign value. Yes. So that's basically it defines the operations here. So what is destroy? So when we define this operations, how do we define them? Is we define the preconditions and post conditions. So for example, the destroy, the precondition is an array of objects that has been previously constructed. And destroy is all storage allocated to the array object is deallocated. That is returned to an available space in the computer, right? So that's precondition of post condition of destroy. Precondition means before you can do this destroy operation, these conditions has to be met. And post condition means after you conduct this operation, all these conditions needs to be met. Okay. So that's destroy, retrieve, and assign. We use preconditions and post condition to describe the method. Also, we can use this kind of figure to describe let me see what we're describing here. 2.2 provides a conceptual picture of an array and shows the effects of the retrieve and assign operations. Okay, we can use this figure to further explain what is happening when we're conducting these operations. Okay, remember those? It's available in D2L. Okay, when we are trying to do the abstract data type, first we have three things we need to specify. The description of the elements, for example, array, index, and the data elements. Okay, so the description of the elements. And then second, it's the description of the relationship between the individual components in the data type. We need to define how they are related. Okay, index and the data items. We use index to access the data items. The first index is associated with the first elements. The ith index associated with the ith data elements. Okay, so that means the relationships between the components. All right, and third is we need to define the operations we wish to perform on the components of data type. Okay, components of data type. Okay, so right now it's in class exercise time. Please take out a piece of paper and now I want you to define an abstract data type. Stack. Okay, stack. Remember those three elements? We want the description of elements, relation between the elements, and the operation of the elements. Okay, in this manner. First is the definition, part of definition. Okay, you define the definition. In the definition, you define what are the elements, what are the relationship between the elements. And then you define, okay, here I just want you to define maybe 3 functions here. All right, define 3 functions you wish to have in the stack, maybe 3 or 4. Okay, and use the precondition and the post condition. And if you think it's necessary, use one of the figure to do this task. Okay, just try to simulate the way we're defining the array to define a stack. Okay, define a stack. You can see? Well, yeah, just using a computer. 4 more minutes for this. Maybe that's not enough. Abstract data type, not array, stack.
Yes, I'm saying an example. Do you want us to do like specific like array?
No,
of
if
customers?
it's specific, it's not gonna be abstract data type. So yeah, general. Okay, yeah, I think, yeah, we don't have a lot of time now. So now let's look at what I did in this stack definition. Okay, I will upload this to DSL as well. So this is a very good example, very good case that we use stack to solve problem, right? We try to pair the parentheses. You know how to use that, right? I'm not going to demonstrate more. So that's some basic knowledge. Okay, so when we're doing the stack, so we'll give the definition. It's a collection of identically typed elements, one on top of another. Identical type of elements, one on top of another. We place the new item on the top of stack, and when we remove an item, we take it off the top of the stack. Okay, so the elements are the data elements of the data are just the elements. Okay, so and they must be, the relation is they must be identical, and they are putting one on top of each other. Okay, and also that's the elements. We define the elements. What are the elements? So they are elements, data elements, and the relations is they are identical and they are on top of each other, and the new item on the top of the stack. And when we remove an item, we take it off the top of the stack. Okay. All right. And also when we define the operations, for example, the push objects. Here I'm just describing the functionality of pushing push operation. So it's insert object X at the top of the stack. Okay, insert at the top of the stack. So that's push. We push the one object on the very top, and when we push another one, it's gonna be on the top as well, but it's gonna be on top of the old top. Okay. And the precondition and postcondition, can anyone tell me the precondition and postcondition of push?
The precondition is the stack object has been previously created.
Yeah, there should be a created and space for this stack. Yes.
And then the post condition in the stack has a top item.
Yeah, the post condition should be that object
That object
is on the top.
is on
It's the first object. The object X is the first object on top of the stack. And the precondition, we just need a space for the stack, but the stack can be empty. That's fine. Yes, that's fine. And here is what I do. I use a figure to demonstrate what is a push. So like before and after. Before we have it's just one case of push. We have 3 elements, and after that we have the X elements on top of everything. That's a push. And also we have pop, peek. We can use a similar way to demonstrate what are they and what their preconditions, postconditions. Or if we think that's not clear enough, we can always give a figure to demonstrate. Okay. All right. I think that's about the time for today, and we will talk more next time, next Tuesday. All right, I'll see you next Tuesday. All right, I said I'm going to take attendance. Okay, this is not about online course, so I'm gonna stop the recording now.
So we don't have class on